Hello everyone and welcome to another episode on this very channel. In this very tutorials, we want to look at this particular question on the board, and this question falls under compound events. Remember, we are still on the same topic, probability. If you haven't subscribed to the channel, kindly hit on the subscribe button for me. So let's get started. What does the question say? Now the question says that in a contest, we have Julius, Okai, and then Asamoah are asked to solve a mathematical problem. Their respective probability that they solve the problem are 1 over 6, 1 over 8, and 1 over 3 respectively. We want to calculate the probability that none of them solves the problem, only one of them solves the problem, and at least one of them solves the problem. These are tasks for the day, and we are going to go through. As I said in my previous videos on compound events, to be able to understand and solve questions on compound events, then you should understand the addition law, the multiplication law, and the complementary rule of probability. Because these three laws plays a key role when solving questions on compound events. If you have not watched the videos on these rules, kindly go back and watch them, and then we revisit this question again. So what we are saying is that there is a contest, let's say the science and math quiz, okay, contest, and then we have Julius Okai and then Asamoah. These three contestants are being presented with a mathematical problem, and then they are asked to solve it. Their respective probabilities that they solve the question are given in the question as that. We want to find the likelihood that none of them solve the problem, the chances that only one of them solve the problem, and then the probability that at least one of them solves the problem. So let's get started. So let's use their initials to represent them. So we are going to use J for Julius, and then O for Okai, and then A for Asamoah. So we can say that the probability that Julius solves the problem is 1 out of 6, and then probability that Okai also solves the problem, we have 1 over 8, and then probability that Asamoah also solves the problem is 1 out of 3. Now once you know their respective probabilities, you can proceed to solve all of these events. So let's start with the first one. None of them solves the problem. Now when we talk about none of them solves the problem, it means that when the question was given, Julius was not able to solve the question, Asamoah was not able to solve the question, and Okai too was not able to solve the problem. So none of them was able to solve the problem. None of them was able to solve the problem. So in probability, we can say that Julius was not able to solve the problem, and Okai was not able to solve the problem, and Asamoah too was not able to solve the problem. So we can write it as the probability that so we can write it as probability that Julius was not able to solve the problem, and Okai was also not able to solve the problem, and Asamoah too was not able to solve the problem. Now this N in probability means the intersection, and it corresponds to the multiplication law. So this means that we can write this as that probability that Julius was not able to solve the problem, and Okan was not able to solve the problem, and Asamoah too was not able to solve the problem. We are using the bar to denote each of the contestants not able to solve the problem. In other books, you see something like, if you are using J, you see something like J complement or J prime. So this J bar, J complement, J prime, it means the same thing. It means the complement of what? J, which is the same as J not able to solve the problem or J not occurring. Good. So we can write it as probability that J was not able to solve the problem, that is Julius. The N means the multiplication law. Then we have probability that Okan was not able to solve the problem, multiply probability that Asamoah too was not able to solve the problem. Now within the question, we were given the probability that each of the contestants solved the problem. So this is Julius solving the problem, Okan solving the problem, and Asamoah solving the problem. But here we are saying that Julius is not able to solve the problem, Okan is not able to solve the problem, and Asamoah too was not able to solve the problem. So we have to find these probabilities. When we were looking at the complementary rule of probability, we said that the probability of an event occurring plus the probability of its complement, which is the same as the probability of that event not occurring, which is written as this, is equal to 1. If that is the case, then we can say that the probability that Julius solved the problem plus the probability that Julius could not solve the problem must give us 1. So we can use this to help us find the probability that Julius was not able to solve the problem. 1 minus probability that Julius solved the problem. So we have probability that Julius was not able to solve the problem will be 1 minus 1 all over 6, and that gives us 5 all over 6. So the probability that Julius could not solve the problem is 5 over 6, so we can write it as 5 all over 6. Then we have times. Let's look at the probability that Okan too was not able to solve the problem. Probability that Okan was able to solve the problem plus the probability of its complement must give us 1. So probability of its complement is equal to 1 minus probability that Okan solve the problem. So we have 1 all over 8, and that gives us 7 all over what? 8. So probability that Okan was not able to solve the problem is 7 all over 8. Now let's look at Asamoah too was not able to solve the problem. So you can say the probability that Asamoah was not able to solve the problem will be given as 1 minus probability that Asamoah solved the problem. So we have 1 minus 1 over 3, that gives us 2 all over 3. So we have 2 all over 3. Now once you have this, you just have to multiply them. So the numerators will give us 70, and then when you multiply this, we have 144, and this is giving us 35 all over 72. Very, very easy and then simple. So therefore, the probability that none of them solves the problem is 35 over 72. Let's look at only one of them solves the problem. So we want to look at the probability that only one of them solves the problem. Only one of them solves the problem. So this means that when the question was given, it can happen that it is only Julius who was able to solve the question. Or it can happen that it is only Okai who was able to solve the question. Or it was only Asamoah who was able to solve the question. So we can say that when the question was given or when the question was presented, Julius was able to solve the problem and Okai and Asamoah were not able to solve the problem. Or Okai was able to solve the problem and Julius and Asamoah were not able to solve the problem. Or Asamoah was able to solve the problem and Julius and Okai were not able to solve the problem. That is the meaning of only one of them solving the problem. Remember, we are having three people, three contestants. So we can write it as the probability that when the question was given, Julius was able to solve the problem and Okai was not able to solve the problem and Asamoah too was not able to solve the problem. So within this event, you can see that it is only one person who was able to solve the problem, and that is Julius. Or we can have, or it can happen that Julius was not able to solve the problem, and Okai was able to solve the problem, and Asamoah was not able to solve the problem. So with this instance too, it is only one person who was able to solve the problem, and that person is what? Okai. Or it can happen that Julius was not able to solve the problem, and Okai too was not able to solve the problem, and Asamoah was able to solve the problem. So within each of these, only one of them solved the problem. With this, it is only Asamoah who was able to solve the problem. With this, it is only Okai who was able to solve the problem. And with this, it is only Julius who was able to solve the problem. So only one of them solves the problem. And this is that. Since we are having the intersection, we are going to use the multiplication law and then the all means addition in probability. So we can write this as probability that Julius solved the problem multiplied by probability that Okai was not able to solve the problem multiplied by probability that Asamoah too was not able to solve the problem. The all means addition. We can write this as multiplied by P of O multiplied by P of A complement. The all means addition. Then we have P of J complement multiplied by P of O complement multiplied by P of A. Now once you have all of this, we are just going to plug in their respective probabilities. So P of J means P of J, Julius was able to solve the problem. So we have 1 all over 6 multiplied by O complement, we had 7 all over 8. P of A complement, we had 2 all over 3. Then we have the addition symbol. P of J complement, we had 5 all over 6. P of O, we are having 1 over 8. P of A complement, we had 2 all over 3. Then P of J complement, we have 5 all over 6. P of O complement, we are having 7 all over 8. P of A, we have 1 all over 3. So the rest is multiplication and addition. So the top, 14 all over 144 plus, this will give us 10 all over 144 plus, this will give us 35 all over 144. Since the denominators are the same, they are adding, we can pick one of the denominators, 144. We add the numerators, that is what? 59. So the probability that only one of them solves the problem is 59 all over 144. Very, very easy. Let's look at least one of them solves the problem. At least one of them solves the problem. So we are looking at probability that at least one of them solves the problem. At least one of them solves the problem. So with the complementary rule, as we said, the probability of an event occurring plus its complement must give us what? 1. So probability that at least one of them solves the problem, we can also use the complementary rule to help us find this. So probability that at least one of them solves the problem plus the probability that none of them solve the problem should give us 1. So to find this, we are going to have probability that at least one of them solve the problem is equal to 1 minus none. Probability that none of them solves the problem. So to find this, we are going to have 1 minus probability that none of them solves the problem. And this is going to be the complement of at least one of them solves the problem. So we have 1 minus none of them solves the problem. I guess we had 35 all over what? 72. So when you do your subtraction, we are going to get 37 all over 72. Very well. So the probability that at least one of them solves the problem is 37 all over 72. This brings us to the end of today's lesson. See you tomorrow. Bye bye.